This is my anatomy project for the sliding filament theory, and sorry it's not the best well made or drawn, but I did what I could. And so this is my step one. Step one is an electrical simulation of action potential from the somatic nerve up here, and this is when it travels and arrives down here at the neuromuscular junction, which is where the somatic nerve and muscle fiber meets up, and then the action potential stimulates the cells. That's step one. Step two is where acetylcholine is released from the action by the way of action potential, and then it's going to start moving to receptors down here called the motor end plate, and this is on the sarcolemma, and that's step two. Step three is so acetylcholine is now going to bind to the receptors on the motor end plate, and it's going to cause depolarization of the sarcolemma. And basically what that means is when action potential causes an opening of the channels down here, and that causes the entry of sodium ions inside the cell. So this is step three. And so this is going to be step four. And so step four is a deposition is continuing. And so the deposition is continuing to happen while the Na plus ions are going in deeper into the muscle fiber. And that's step four. And so step five, into deposition, is continued even further into the muscle, and it goes into the T-tubules, which are this right here. And then, and that changes the SR shape. And that's step five. And so now we have step 6 and 7. And so step 6 is going to be when calcium is released from the SR. And that's just what step 6 is. And then step 7 is when it binds to these things right here, which are called the troponin, and these are on the actin or thin filament, and that's what step 7 is. Steps 8 and 9. So step 8 is going to be, so since a protein was added right, since the troponin, the actin must change its shape. And when it changes shape, it turns into tropomyosin, and then exposes a binding site on here. And that's step 8. And step 9 is when the myosin head right here, the myosin head is going to bind up here onto the tropomyosin, and this is going to make a cross bridge. And the cross bridge is basically just the distance between the actin and the thick filament down here. And now we have step 10. And so now the myosin head has already binded to it, and it's going to turn or pivot and pull the actin inward, and it's going to shorten the whole sarcomere and contract the muscle. And whenever this happens, this is called the power stroke. And that's step 10. And so now there's step 11. And so the myosin head is going to 11 and 12. And so the myosin head is just going to release from the actin, and the cross bridge, which was over here, was broken. And then another ATP is going to bind. And then that was step 11. And then once the myosin head goes back, step 12 is when the myosin head goes back in the ready position, and the ATP comes off, and an ADP and a P come onto it. And then these last 3 steps are going to keep continuing until all the calcium from the whole muscle goes back. And those are the 12 steps of the sliding filament theory.